Hi everyone, myself Dr. Sheena. So today we'll be dealing with the topic the obturation materials and obturation techniques. So after the working length determination, cleaning and shaping or the biomechanical preparation, the next important step is obturation and the obturation materials. So the classification of endodontic obturation material in the early times we used silver points. Nowadays we are actually used the most currently used material is like the gutta percha, mineral trioxide aggregate and resilient. So talking about silver cones, silver cone is actually very easier to place within the canal because it is very rigid. It is like a file, like a silver, like a stainless steel material, which can be easily placed into the root canal. The disadvantage is like it enabled to have a proper three-dimensional obturation. Is not taking place. There will be large amount of voids, and sometimes the because of the contact of the silver points with the fluid and saliva, it might cause actually corrosion. So advantage is like it can be easily removed even during retreatment because it is in a single unit. So once we actually pull it out, it might actually come very easier. So the question is like corrosion of silver cone is due to the presence of the corrosion of silver cone is due to the presence of nickel. The silver cone contain traces of metals like copper, nickel, which adds up the corrosion of silver point. So mainly the nickel and copper is actually responsible for the corrosion that is actually taking place in the silver cones. Next is Gutta Persha. So Gutta Persha, talking about Gutta Persha is actually a trans isomer of polyisoprene. So this is very important. It is a trans isomer of polyisoprene, which you can memorize it as the code TIP. So it commonly contain the composition of actually 20 percentage of Gutta Persha, which is the matrix, onto which there is about 65 percentage of the zinc oxide, that is the filler particles, and it contain a radio opacifier, that is about 10 percentage, and the wax which actually act as a plasticizer in that. So this is the composition. The question might be like, which is the ingredient which is commonly like greaterly present in the composition of Gutta Persha. So don't get confused, it is not Gutta Persha, it is zinc oxide which is actually present at about 65 percentage quantity. So coming to the characteristics of Gutta Persha. As I said, Gutta Persha is trans isomer of polyisoprene. So we actually extract it from a tree and it is converted into resin form. So we know that we get it as a solid form. The solid form is actually beta phase. Very important. The form which it is available is actually the beta phase. So the beta phase can actually convert into alpha phase. Alpha phase is actually the flowable phase or the tacky phase, right? So this is almost at a temperature of 42 degrees centigrade, and this is almost at a temperature of 54 degrees centigrade. So beta phase is actually the phase which we see as it as solid phase. The beta phase, when we apply heat, get converted into actually alpha phase, which is more tacky, it is actually flowable type into the canal, right? The thermoplasticized alpha phase shrink as it set into the solid phase. So in thermoplasticized Gutta Persha, the hard or the solid Gutta Persha get converted in the alpha phase and it flows into the canal. Once it flows into the canal, they sets there, right? Sometimes as time passes, the Gutta Persha become like it become hard, or sometimes it become like powder like structure. So for rejuvenation of the Gutta Persha, what we to need to heat at a temperature of 55 to 59 degrees centigrade. So this is another question that was asked for your NEET MDS PG. So, Gutta Persha is plasticized or softened by what? So, normally it is actually plasticized by actually chloroform. So, chloroform is the answer for this. The primary Gutta Persha cone must fill the canal wall tightly in the. We know that when we prepare the root canal, the taper is towards the apical area. So the Gutta Persha which we place should have a tug back at the apical third of the tooth. As I said, what is chloroparcha? Chloroparcha is actually obtained by mixing the gattaparcha with chloroform, and we'll be actually fitting into the canal. Once the chloroform evaporate, they sets to form the gattaparcha structure. So that was all about the normal materials that is commonly being used for obturation. MT will be dealing later. So talking about the obturation technique. First of all, Grossman have given some of the obturation techniques like cold lateral condensation, warm vertical condensation, continuous wave compaction technique, MX parents technique, thermoplasticized Gattapasha technique, carrier-based Gattapasha technique, chemically plasticized Gattapasha. So you need to know the difference between different obturation technique. First is lateral condensation technique. So we know that normally this is actually the tooth, and we will be doing the cleaning and shaping of the root canal. First, we will be placing the first master apical file. Master apical file is actually the master apical Gattaparcha cone. So, master apical Gattaparcha cone is that fit the apical part of the tooth. Once it fit into the apical part of the tooth, what we have to do is like bring a spreader. Spreader is a instrument that is actually used to create the space for the accessory cones to take place. So we'll place the spreader, we'll push by using a spreader will be actually used, and we'll push here, we'll create space here, and after that accessory cones are placed and filled in this space. So that is called as lateral condensation. We'll keep a master cone inside, we'll bring about a plugger and a spreader, we'll make some space, and lateral accessory cones are placed and condensed. That is called as lateral condensation, and this is one of the traditionally used method for sealing the root canal. So as you can see in this image, the canal, the master cone is actually placed, and a spreader is used to make space. The space is actually filled with accessory cone. Now the obturation is done. Now, what is vertical condensation or warm Gattapasha technique? It was introduced by Shielder. This is very important. This is also a neat Viva question. So, what happens is like whenever we do a root canal, uh, after cleaning and shaping, we will be placing the master cone. Once we place the master cone, what we does is like with the help of a heated plugger, we will be pushing it down. We will be pushing the material so that it is completely filling the voids and all the areas where space is being present. But the problem with vertical condensation is like we are pushing downwards, and the pressure is being built on the lower surface. So what happens is like there is chance of actually vertical root fracture. Sometimes vertical root fracture might actually take place. So that is about the vertical condensation, also called as warm Gattaparcha technique. Next is system B. So system B is actually a machine that continuously give a heat source which is applied to the gattaparcha. So what we does is like we'll be applying softened gattaparcha in the apical 4 to 5 mm, and we will be obturating, and after that application of sealer is done, then we will be placing the master cone, and the heat application is done in the apical 1/3 of the area. Next is sectional method. Sectional method means from outside itself, we will be actually cutting the gattaparcha to about 2 to 3 mm, and that will be actually placed within the canal, that in a sectional manner. So in sections we will be actually obturating it. This is called a sectional method. Why this is done is like this is mainly done to actually remove the voids that is actually present in the canal. Next is thermoplastic gattaparcha injection technique. It means that there might be a gun or there might be certain materials that is present. So all these thermoplastic materials are in the alpha form itself. The lateral condensation and cold condensation, vertical condensation, we use beta form solid materials. Here, the outside the canal itself, the gattaparcha is heated and it is poured into the root canal. Understood? There are two type. Low temperature system is there, high temperature system is there. Low temperature system uses a temperature of 70 degrees centigrade, and high temperature system uses 160 degrees centigrade, and the example include ultrafill here, and this include CEO, that is the calamus, elements, and obtura. This three system actually uses a higher temperature. Where the gutta is heated outside, it is actually poured into the root canal. So the syringe insertion method is it. This was actually based on the temperature. Now syringe insertion with or without the gun is there. First, with gun, there is beta phase has been actually used and alpha phase is used. Obtura technique use the beta phase. Important. So we know that beta phase is solid. So that has to be converted into alpha phase. So there is large amount of heat is required. Ultrafill, it is present as an alpha phase itself. So it can easily flow into the root canal. Simple. Syringe insertion without gun is inject R fills. Other injectable technique are like calamus, element obtura unit, hot shot delivery system, gutta flow obturation system. Just know the name. So here you need to know the obtura system require more of a heat because it is using beta phase where it has to be converted to alpha phase. Large amount of heating is required. So the question is, high heat obturation technique refers to. So we have already studied is Obtura 2 because Obtura 2 is in the alpha phase. It is in actually it is in the beta phase. So in order to convert into the flowable form, it has to be heated. Next is Mex pattern's compaction method. You can see in this image, Mex pattern is actually having a hedge file shaped structure onto which the gutta percha is actually embedded in that. So what happens is like it is a rotating compacting instrument. We'll be actually applying into the canal. It will move at a speed of 8,000 to 10,000 rpm, and what happens is like because of the compactor forces the gutta percha to slowly soften and move into the canal. Okay, that is the Mex parents compaction method. Another is like chemically plasticized gutta percha. So what we does is like we use the gutta percha, we will dissolve in certain dissolving materials like chloroform, eucalyptol, xylitol, etc. so that it can actually soften down and move into the fine and curved torsus canal. So these are actually the methods when you actually study about obturation. First of all, we have to know the various obturation techniques. That is important, and along with that, the obturation materials like gutta percha, silver cones, etc. has to be studied. So whenever we do obturation, obturation should be such that it produce a hermetic seal, a three-dimensional obturation, and where we need to actually stop the obturation. That is important. Just think that this is the root canal. Normally, obturation is actually done 0.5 to 1 mm short of the radiographic apex. So the obturation will be like this. That is to avoid irritation in this area and to avoid the periapical extrusion of the obturating material, etc. So hope you had a great class and we'll see you in the next class. Thank you.